Good evening, everyone. On behalf of Division of AML, Karunya Institute of Technology and Sciences, Coimbatore, I welcome all of you to day two sessions. Today, today's session will run from 6 p.m. to 9 p.m. Let's get started. I would like to read some of the instructions for participants in the beginning of the session itself. There will be two sessions today. Only one feedback form needs to be filled today. The feedback link will be shared at the end of the session. And please note down your participant ID from the email communication. Also, I have posted in the WhatsApp group once again for your reference. Because this participant ID is required for filling the feedback form. For technical queries, kindly post your queries in the chat box in between the session, and that questions will be addressed at the end of each session. You can participate in the discussion through your chat box. So I would like to introduce the resource person for today's session. He'll be conducting for both sessions. He's our Dr. C.S. Saravana Kumar. He's the senior architect at Bosch Global Software Technologies in Coimbatore. He has completed his doctorate in semantic web mining from Katpagam Academy of Higher Education, Coimbatore in 2020. With 14 plus years of experience in the IT industry, he has held various technical and leadership positions at Bosch, Cognizant, and Intel. His professional journey includes roles as a subject matter expert, senior software architect, specialist at Bosch Global Software Technologies, as well as associate at Cognizant and an intern at Intel. Dr. Saravana Kumar has made significant contributions to computer science, particularly in cloud computing, data security, and artificial intelligence, with several technical papers published in esteemed journals indexed in Web of Science and Scopus. Currently, he is pursuing his postdoctoral research at Lincoln University in Malaysia. He'll be discussing two topics today. Topic of session one is exploration of quantum computing, and topic of session two is quantum computing implementations and applications. Welcome, sir. Now you can take the session.
Okay, thank you, ma'am. Hope my voice is audible.
Yes, sir. It is
Okay,
audible.
okay. So hello everyone. Good evening again from me. So the one painful thing is when we are connecting from home. First is the network issue, and second one is the disturbance that we get, from from everyone. Yeah. So I've tried to lock the room. So in case of ma'am, of course, any disturbance, sometimes my mic might get disconnected or something, or if you're not able to get my voice, please let me know, ma'am. Yeah.
Sure, sir. Sure, sir. Please proceed, sir. Thank you.
Okay, ma'am. Yeah, then let's start. I will share my screen. Okay.
So click on the share button and you can share.
Yes, ma'am. Hope
Yeah,
my
your entire
screen is
screen is
visible.
visible, sir.
Perfect, perfect.
So you can
So
for
I
slideshow and you can.
Oh, perfect. Yeah.
Yes,
So
sir.
yeah. So basically, so today I'm also now, apart from, I'm leading the AI department at Bosch, Coimbatore. So, as ma'am given me a beautiful introduction, but I'm actually responsible for the AI ML activities. I work on the innovations bits, mainly on the European region for the customers. And so, especially my specialization is on multi agents and quantum. So a car is communicating to another car, how the communication is done on the multi-agents involving AI, and of course on quantum. So that was also my an area of expertise. And inlining towards it, yes, I have also started my postdoc in quantum AI from last September, at Lincoln University, Malaysia. So that is a short about me, what I do in the company, and today it's like, again, as I'm also a kind of like a student. I wanted to, in with respect to quantum, doing my research. more and more, I wanted to share my insights, what I'm working on, uh, so mainly I will try to make it interesting. So I wanted to convey you like what quantum computing, of course, because this is not a new buzzword. Now everyone would have heard about what is quantum, what is quantum computing. At least everyone is aware that quantum is very complex, and but it can solve any problems. So this information is known by everyone. So today I really wanted to give an at least a good insight on what I know with respect to the quantum that can help or kindle us, or maybe on the research perspective where we can head up with respect to the quantum. Because if you think quantum, generally if you look into the trend cycle, normally you will have the trend reports from Gartner. This is a famous Gartner reports that will be published every year. And so normally you will be getting the Gartner trend report every quarter, every 6 months, every year they will publish it. Like they will actually give a projection, like McKinsey, Gartner, and everything. When they projected the quantum was in as a horizon 2 topic. So basically we will tell, like, Gen AI is present, Gen AI is present, and maybe explainable AI is a horizon 1 topic. That is maybe the topic will get impacted, or it will come into existence within 1 to 2 years. And there is a horizon 2 topic, it is between 2 to 4 years, and horizon 3 is like 4 to 6 years. So basically the quantum computing, whichever was in a horizon 2 topic, that is, people believed that 2 to 4 years quantum will be available to all people. It will have a potential impact in all years. But now they have predicted that it may fall into horizon 3 topic. So we had a debate. I was in a interesting discussion in Renningen, Germany, on quantum. I was meeting some experts on quantum, and so we were actually having a discussion, because we were having a healthy debate, like, why it was, why there is a shift of quantum from horizon 2 topic to horizon 3. Because, but it is shifted from 4 years to 4.5 years, to be very precise. So that's why people call it as horizon 3 topic, but actually it is a horizon 2 maybe. But people are also working on, to get the benefits of quantum computing so fast. Industries have invested. Industries have invested on quantum. Government of India, if you take, if you are following the investments, and of course that is why we have ATAL, FDP, on quantum. But if you take from 2020, the investments from Government of India, it was like from 8,000 crores, and even in the recent financial budget, that is, I'm talking about not 2025, it was last year financial budget, when it was allocated for quantum, they allocated 6,000 crores. And so the government foresee quantum to be the solution for bigger complex problems. So slowly, how Gen AI has taken up the world. So slowly the cycle will be like explainable AI and quantum AI. So the quantum combined with AI for quantum computing, it will take its own flavor, but it will take, like, 3 to 4 years down the line. Uh, you know, it will come. But quantum is the final piece of puzzle in the AI flow, after explain now Gen AI, explainable AI, and quantum AI. So, so inlining towards it, and why, and all quantum AI, whatever stuff people are working, everything is now focused, because we have different flavors: quantum computing, quantum sensing, quantum communication. So all these different, of all different flavors, we are interestingly working on quantum computing. you know because already for COVID we have a solution only with help of quantum. I mean, of course, as a research people, whoever joined here, of course this is not, might not be a new information. Of course, we solved COVID medicine. We discovered COVID medicine using quantum, and with the quantum computers. And with respect to, how the advancements is going on, quantum computing, and if at all uh, you want to invest, and how we can work, because the very first hurdle is people who has already started with quantum, or who, because I also know there is a handful of professors, people now everywhere, slowly also starting their research, PhD in quantum. And the one problem what they face is the system, with respect to the system, how we can use the system. Because IBM, because when you interestingly, if you listen, IIT Madras is working on quantum sensing, and even in some parts of Germany is also working on the same thing. What they are trying to do is, using quantum, they are trying to create artificial diamonds. So by creating an artificial diamonds, people have a fear. I mean, not fear. People wants to utilize the power of quantum, but they want it to very fast. So in today's discussion, we'll be touching on different flavors. Of course, we have started. Many people have started their research on quantum computing, and first of all, quantum computing. But to utilize the quantum machines, wanted to try out how, what are all the, how we can see, or what are all the challenges, what are all the limitations, but how, even to start with, basically with quantum, quantum exploration, what things that we can do, and even quantum computing, and first of all, understanding the quantum, and where the, what are all the research areas that it gives us a handle to proceed, you know so all these on the touch points, I wanted to discuss on I don't know, wanted to have a, a decent discussion in the upcoming minutes, or the in the upcoming hours. Try to, you know try to give you the core informations based on the time. We'll try to make it interesting, and yeah, then let's proceed. Yeah. So on the quantum computing, one thing before I start, the couple of videos I've created, I've not downloaded it from YouTube. Rather than I've created from an app called VideoGen. So I have the license. So in the from the VideoGen, I've created some couple of videos, and some of the videos I wanted to show, which I was also working on in quantum. I just also wanted to show you something interesting applications where quantum will have its effect. So with that, I just wanted to play a video before we start. So let's do that. Oh no, sorry. Uh, ma'am, can you able to hear my video? This voice, is it audible?
Audio is not available, sir.
Oh, okay. But my computer audio will not be here to the other participants, huh?
Sir, your voice is audible.
But the
The video,
okay,
the
then
sound of the video is not audible.
okay, then how can I do that?
Sir, can you stop your presentation, PPT, and can you share only this screen alone? Can you
Uh,
click the share button and share only this video alone, this screen video?
okay, okay, okay. So, huh. So let me know if you can able to see this video, and now, and able to hear the voice.
Voice is not audible,
Not
sir.
there. Okay, okay. My bad luck. But maybe I also have this English. I mean, the kind of like a subtitle. Maybe let's watch. Maybe considering the time. Okay.
Sir, can you able to hear this audio from your computer? In your computer, can you able to hear this audio, sir?
Yes, ma'am. Yeah.
Okay.
Or I can unplug my once again. Just
Yeah, yeah, headphone.
one sec.
stands. Can you able to hear now? At the front.
Yes, sir. Yes, sir. It is clear now.
Perfect. Okay. Then okay. Then I will just play it from the beginning. There. It's just a minute video. Quantum computing.
Sir, can you increase the system volume?
Oh, you want to increase the system volume?
Yeah, full volume.
Yeah, yeah, 100%. Okay. Yeah. It's a maximum thing.
Sir, this is from the player, from your system volume.
Yeah, no, the system volume. Yeah, I've been sorry, not this. I've increased this. I've increased this 100%. Yeah. Okay. Bits can exist thanks to a property. This has speed to traditional.
It's not clear, sir, actually. Audio is not clear.
That's the potential. Furthermore, quantum intake. When a qubit is needed, the state of one qubit becomes dependent, regardless of the distance. This phenomenon could lead to breakthroughs in secure communication. The implications for industry, healthcare, and logistics as not and enhances. However, the truth or practical challenges. Maintaining qubits in their delicate state requires precise conditions and error rates. Research teams are and developing more among tech giants and startups alike. As we stand, the excitement is it promises not just faster calculations, but a fundamental opening doors to solutions that could reshape our world in ways we are only. The future of is not just it's about redefining in the digital age. Quantum states at the frontier, promising to revolutionize. Okay. Unlike classical computers, which use bits as the smallest unit of data. Okay. So yeah. So that is. One second. Okay. So back to my screen. My screen is visible now, right, ma'am?
Yes, sir.
Okay, then I think I can talk without the headset. Okay, fine. So that's why. So that is a short intro about quantum computing. The video that I have prepared using prompt engineering, and fine. So basically, what is quantum computing? I know there are some terminologies that you might have, of course, we would have heard, but I wanted to go. Again, I wanted to repeat on the same, and normally when we talk about quantum computing, before we talk we need to know certain differences. I'm not going to, of course I will tell about the qubits and all, but there are some terminologies that we need to know. That is what is a quantum gate. People normally, when you are starting with quantum computing, or when you are trying to explore quantum, and you will be you should know what is a gate, what is a circuit, and what is a qubit, of course. So one thing is, in a classical machines we are trying to do zeros, 0 and 1. I mean, of course it is represented always in 0 and 1. And whereas in quantum we call it as qubits. Here we have call it as a classical bit, here we will call it as a qubit. And as the name quantum, it is qubit here. And normally qubit can be in any state. So understand a qubit. If you really toss a coin, and when the coin is in, when the coin is tossed, before you look into the coin, before you look into the result or whether the coin is a head or tail, when you toss a coin, the coin will be in both the state. That is, the coin can either take head or tail, and in that state, the coin is actually representing both the state. So normally, exactly, you can compare a qubit. Exactly, you can map that you can have in the quantum computing or in the quantum computers, the qubits are there where it can have zeros and ones simultaneously. I mean, both at the same time. So why quantum computing is very powerful is it is having a solution at the same time. Example, if you want, we will be discussing the one concept, as we progress. When you're trying to solve a maze problem, when you're trying to solve a maze problem, even today, with the traditional computers, with Gen AI and all, when you try to analyze the situations, the system will work, one by one solution. Okay, the system will work like, okay, if I want to solve the maze problem, I have a solution A, I have a solution B, but it will come, sequentially, not simultaneously. But in the quantum computers, when you throw, the problem statement completely for the same maze problem, at the same time, the system will tell A is a solution, B is a solution. Simultaneously, it can throw multiple solutions at the same time. And that is why quantum computing or quantum computers are so powerful, because there is no need for you to wait in a sequential manner. And for that, they use the concept called as qubit, which can represent both the state. It can be head or tail. We don't know, but if it can be head or tail. It will represent both the state at the same time. Whereas in the traditional computer, it can be either head or tail at a given a single time. So a basic difference to start with what is quantum computing. And very interestingly, these are the three things. Again, on the difference, whenever we talk about quantum computers, we always start with difference between the traditional computers and all these, always with at least with the first two principles, superposition and entanglement. But the superposition, it can, as I have told, it can execute where the qubits can execute in the multiple states. That is a superposition. You can keep it simple. Superposition where you can have multiple solutions at the same time. That's why using the superposition, when you are, because when people wants to train a model, because we are trying with different solutions, because as we speak on every slide, I will try to touch base on also on the applications or the use cases what we are actually also thinking or working, or generally researchers taking it on the quantum to make it interesting. So when you are really thinking of the superposition, normally what the people will think is the qubits can, people will take the superposition concept. They are, if at all you want to train a, if at all you want to find a solution, example, optimization problem. So if at all you want to find a solution for an optimization problem, that is, if at all you want to find a solution for, because nowadays electric vehicle is common and many people are working on the optimization problems. Now, why we are involving quantum for smart cities? Because you need to, the very first thing is you need to do an optimization. And the first optimization is on the traffic. Example, if I want to do, because now as we speak, Coimbatore is also in the 30 of listed, the first level of 32 cities, which is planned for smart city. Coimbatore is also one, along with all Delhi, Mumbai, Pune, Patna, Pune, everything, Noida. But with the very first thing, even if you take Delhi, if I want to convert Delhi as a complete smart city, the only smart city that exists in the world using quantum principle in the world is the only country, and that is Singapore. Till now, no other country has achieved it. Only Singapore, maybe due to the size, I don't know. But the Singapore has achieved the complete smart city concept using quantum principles, and it is the only country. So basically, if you try to optimize something, example, traffic optimization, and we will be talking about different terminologies on the traffic optimizations. But basically, when you are trying to optimize something, see, even now, we are studying in our newspaper that when a green corridor is implemented, we all know that what is a green corridor. I mean, green corridor is like when you travel, when you have 10 signals in a straight road, when you are on a 40-kilometer speed on the first signal, when the first signal turns green, and when you are on a 40 kilometer per hour speed, the remaining all 9 signals will be in green when you try to reach over there, such so that You will cross all 10 signals without waiting. So that is the green corridor. But we have implemented our own green corridor also in Coimbatore, but we are not able to do it successfully. But even here, the optimization is required. Traffic optimization. Traffic optimization is a very common problem that we are trying to optimize it. Even if we are trying to achieve the smart city concept in Delhi, the very first thing is traffic optimization. Second one is the air optimization. Air, the filtering of air and making it clean. The optimization problems. And for all those problems, even with all the GenAI and advancements, we were not able to do it. Because we were not able to do it, we were not able to represent different things, but that is a different story. But using quantum, this is achievable, and Singapore has already proved it. And that's how using superposition concept, where you can represent multiple conditions at the same time, that the system can decide. If you are trying to develop a decision engine, and if you are trying to develop a decision engine with principles of quantum or a quantum computing machine, where you apply AI, where the decision engine is working on, on the quantum machine is trying to decide whether to turn on the signal of the traffic or how to optimize the traffic. This is one of the best way, because multiple scenarios at the same time. System no need to wait for the system, no need to wait. The system can decide, make decisions spontaneously. And entanglement. So coming to the next topic, entanglement. Entanglement is kind of like two particles connected to each other in simple words. So how, if I do that, someone will get affected. If that is a situation, that is entanglement. So example, I again don't want to take the example of a coin, but if you have something, if you are sending a birthday gift to two different friends, on the same day, and if one friend is opening a gift box and seeing that, okay, he got a gift A, and you will definitely know the other gift is with the other friend. Or how you can say is, if a state of a change of a particular object is trying to influence the other object, that means I'm sending again, I just wanted to take coin because easily I relate everything with coin, because we play with mathematics with quantum. So coin is the best one. So when you flip a coin, and we know that unless until it is in the air, we know that it can be of anything, head or tail. And when you see the result, if it is a head, obviously the other side will be tail. So one state is trying to influence or affect the other state. And where entanglement is using is, we are working on a very very old topic called as dimensionality reduction from the existence of data mining. So where people are working on the data mining topic for a very long time now. But when you take the data mining, one of the important term or important research area is how you can try to reduce the dimensionality vector reduction. How to reduce the dimensionality of a vector. Vector space, we call different terms for that. And entanglement will be used to reduce. Where you are trying to use an entanglement is, you are trying to compress the data. When you are trying to compress the data, you can try to compress the data because and using entanglement, so that when you try to compress the data internally, you will say that when a particular attribute is getting affected, the other attribute will also get affected. So you will have a proper entanglement, you will have a proper chain up. So that's where entanglement falls on. And quantum tunneling. So with respect to the quantum tunneling, particles can pass through, okay, all text I'm leaving it out, but generally when you consider a quantum tunneling, if you look into it, when you are trying to roll out a small ball, over a small bumpy area, the ball can reach the bump area, until it has the energy. But with quantum tunneling, even though whatever energy the ball possesses, it can able to pass on the other. It can pass on, able to pass on to the other side. So how it is very funnily, I've read, in one of the article, I've read this as a very nice, on a lighter note, it is a nice point where it is like a ghost. I mean, when a ghost is actually, it can able to bypass, in movies and all, people were showing like a ghost is trying to pass, the door without the door is being opened. The ghost can just simply go to the other room without the door is opened. Exactly, the tunneling concept is that the particles can able to penetrate to the target area, and even though it has some barriers or everything, they can able to penetrate. So this tunneling is actually, especially when you want to have a safe communication or something, people will be using this tunneling concept that will come later. So these are some of the different principles of quantum mechanics are there, which is used in quantum computing. But these three concepts are very important, but very easy to understand. But it comes in different flavors for different purposes in quantum computing. Yeah. So on the superposition, entanglement, tunneling is what we have discussed. And as I've told you, when you take quantum, we should know the other two terminologies called as state and circuit. So basically, when you are trying to, exactly in a classical machine, when you are trying to add two numbers, example, if you wanted to add two numbers, 4 plus 5, normally it will be represented in bits, zeros and ones. 000 and 0001, 0010, 0011, 0100 is 4, and 0101 is 5. Basically, we have studied this in our lab exams or something in our bachelor days normally. So 0101 is 5, and 0100 is 4. And when you are trying to do an addition operation, you will involve a logical AND gate. And this whole setup is called as classical circuit in normal classical machine. That is, even in my laptop, even in your laptop, whenever you want to do any operations, usually the gates will be, used. The gates can be anything, AND gate, OR gate, or whatever operation that you want to do. For that, specific gates will be there, and that gates will do a particular functionality, and this whole setup is called as circuit. So likewise, in quantum, we have different state, the qubit states and everything. And, you wanted to, you can represent a bit in different states. And you will also have gates applied so that the quantum will work and produce some result. This whole setup is again called as quantum circuit. So there we are calling it as a logical circuit or a classical circuit in our laptop. In quantum machines, we call it as a quantum circuit, because that's why people, when you try to explore any IEEE paper, when you are trying to refer something, people will be always calling it as, hey, I have developed a quantum circuit to perform something. If you refer today's tensor network, so tensor network has proved that it can able to do a search thing very fast. So to make it very fast, what they're trying to do is they can able to, they can able to give a quantum circuit for that. So people will be normally referring as, I am able to provide, or I am able to sketch out a particular circuit that is called as a quantum circuit to perform a faster search, or to perform or to optimize certain things, or trying to simulate something in the classical machines, trying to bring the quantum things in the classical machines. Different things. For different things, different purposes, people tell that, yes, I have quantum circuit which have different state. So now we have gates. We know different states are that. State is nothing but 0 or 1, or both can be on this, or both simultaneously. And the gates will be like, you have different gates to perform, how we discussed in our logical systems, like we have AND gate or we have OR gate. So likewise in quantum also we have different gates. We have poly gates and example, yeah. So we have poly gates, we have controlled NOT gate, and Hadamard gate. Hadamard gate is called as H gate. So normally, if you think of Hadamard gate, H gate is like, trying to implement superposition. So I've told you there are three principles, basically superposition, entanglement, and tunneling. And when you come to the gates, there are three important gates: Hadamard gate, controlled NOT gate, poly gates. You leave out the functionality because these are some of the text, of course, we can refer anytime. But normally, when you take the H gate, the H gate is actually used to perform superposition, and control NOT gate especially performs the entanglement. So normally the control NOT gate will do like, I don't need to confuse you because or bore you guys in talking about the control not gate. But normally control not gate, each has its own way of using it. So it's like, control not gate, you have a control bit and a target bit. And when control bit is 0, the target bit will never get affected. And when control bit is 1, the target bit will get affected. So that's why, very interestingly, in controlled not gate, 1-0 will become 1-1. Because if you consider 1 as your control bit and 0 as your target bit, the control bit is 1. So whenever when the control bit is 1, the target bit will change its position. So 1-0, obviously the output of 1-0 will become 1-1. So like why we are talking about this is, this control not gate will always implement, even if it is confusing, you leave it out. H gate is used for superposition purpose, control not gate used for entanglement purpose. And poly gates is used for quantum error corrections. Simple points. Even if something, whatever I've said in the last minute, if it is confusing, first thing is superposition, entanglement, and quantum correction. Poly gates. So why we use these gates is, using these gates only, you will set up a quantum circuit where you will prove that, okay, this circuit will address so on and so forth. Like how we prove in our normal algorithms. We take GenA algorithms, we take an LLM, we take normal large language models, and we say that, okay, this large language models, I have extended this large language model and I have achieved something. And even if I want to go back one step before that, people who are working on a normal machine learning algorithms, deep learning or neural networks or anything, in neural networks, you will be taking some hidden layers, or even let's keep it very simple. We are working on a naive based algorithms, and we say that, okay, this is a optimized naive based or a novel naive based algorithm where I have my own approach, because naive based produces only these results, and my approach, I'm addressing these things exactly like that. So you can actually say that using superposition, I am able to speed up certain things. So I've told you already, using superposition, you can able to speed up certain things, and using entanglement, you can able to compress the data. Compress the data means, again, time taken, or for the search things, because normally entanglement, the chain up is done. So whenever you wanted to do a search thing, entanglement is used. So you can actually say that I have my own circuit, quantum circuit established, where I'm addressing the entanglement, how the data is chained up in a different way, so that I am having a unique approach of even addressing these scenarios. Of course. So only for that, everywhere, commonly, if you go, you have this H gate, control not gate, and poly gates spoken everywhere. So we need to know what is a circuit. Very simple. Circuit is a flow of gates. It's called as quantum circuit, and we have qubit as a state. Very simple. 3 things for us to start exploring, or to start, if you find quantum computing as an interesting thing. And now, considering the quantum algorithms and their advantages, exactly like as the gates speak, and as qubits we have, using quantum computing, what are the things immediately we are into it? So very first thing is always, always, we are actually working on faster search algorithms. We are actually, have an improved cryptography. Why means, people are actually afraid now. You really think one situation is going to occur. You have developed a secure key using an RSA algorithm, and you say that you cannot break that security, by any hacker for 3 years. We are very happily say that the secure key, what I have generated using an RSA algorithm, that no one in the world can break, and it will take 3 years for a super performing system that is available today. It will take 3 years to break. A quantum machine, a quantum computer can break it in 3 minutes. Now this is a threat. Now everywhere in the world, there is a plenty of researchers who are working on the cryptography, how things could be secured using quantum things. Okay, you are securing things, but also people also working on, if something is if some hacker is using the same quantum, break the encryption, how to secure it. So that is a fascinating research. The whole world is working. Of course, we are also working. Bosch is also working, and because we wanted to secure the data, because every car what you run using the Bosch chip, because people, whenever I communicate, I always tell Bosch, we are not into the electrical appliances. We have electrical appliances as a secondary business, but our predominant product is the chip, which every car, starting from Maruti 800, Nano, Audi, Jaguar, Ferrari, out of 100 cars in the world, 85% of the cars is running with Bosch chip. So that chip will determine how much petrol that you have to push, how much petrol it has to flow when the vehicle is in the petrol or diesel in the vehicle in the first gear, second gear, third gear, fourth gear, automatic, electric vehicle, whatever it is. So that through that only we make money. So here, if you think, we are, the system, we have intelligence, the ADAS mechanism, the automatic driving, it is provided by Bosch to most of the companies. That is the automatic car that brakes when people are crossing on the road, when you are trying to, when a vehicle before you stop, there is an intelligence that we have provided, artificial intelligence, that the system will actually calculate. Again, it is for debate, because I already got into a debate with one of the senior researchers, that here we produce an intelligence, it will calculate, like, if I stop the vehicle, or if I stop it suddenly, the vehicle behind me, whether it will hit or not, or to save him, I have to go and hit the previous vehicle. So how the intelligence decides, how much parameter it flows, how it decides everything. So we are actually dealing with, every day we are dealing with so many data on the computers. So we also want the future to be secured. We don't want anyone to hack the machine and take control of the car. So quantum, as it provides advantages, it is also posing a threat. So research are ongoing, because this might be a bigger topic in next 3 to 4 years, is what the prediction. So that's the advantage the algorithms have, different algorithms have, that we need to be aware of. Because whenever we are talking about machine learning, we talk about naive-based decision trees, support vector machines, KNN, as a basic algorithm, neural networks and everything. So likewise, in quantum algorithms, we have certain algorithms. We are not going to discuss the algorithmic flow or nothing, but we also need to know there are some quantum algorithms which is very fascinating, which is already having an impact in our lives slowly. So that's what we wanted to discuss in the next few minutes. Considering the time, we move on. So this is a small. I love this picture. I have created this picture. So this is a small globe, where you can actually see how the quantum algorithms. What are all the quantum algorithms fascinating it? There are, like, 5 main algorithms. If you ask me, like, okay, Saravanan, we are working on quantum computing, and we wanted to use something, and even we wanted to use something, and what are the different algorithms, and this is a composition of different algorithms, that if you see, these two terms you might have heard everywhere: Shor's algorithm and Grover's algorithm. Of course, we will tell what it is about, because today I don't want to get into detail of anything, but my idea, as I've said it in the beginning of the session, I wanted to give a taste of what quantum computing beyond what we think, and what are the different areas of research where we have opportunities and what is coming. So if you really think, we have Grover's algorithm, and we have Shor's algorithm, and we have optimization algorithms, we have walk algorithms, we have HHL algorithm, yeah, and so each has its own purpose. So starting with a Shor's algorithm, and if you look into the Shor's algorithm, and basically Shor's algorithm is what I have spoken of. Using Shor's algorithm, cryptography definitely can be improved. How? Using the same Shor's algorithm, you can actually break. How you can break? Like I said, in the RSA encryption, you have done some encryption where it involves factorization of numbers. N into n power of factorization is involved. That it will take a super duper computer that exists today to solve. It will take 1,000 days to solve it. But whereas this Shor's algorithm, when it is working on a quantum computer, it can break it very fast. In few minutes, it will break. It will break the encryption. So, but why we are also having a shows algorithm is shows algorithm also gives us a handle to develop a security. It's like inducing a virus and see how much our solution withstands. Exactly the same. So if you look into that, the shows algorithm explicitly work on factorization of numbers, x power n, how it can break, how it is expanding. More mainly, it shows algorithm is cryptography. In cryptography, it is used. So the users is like the crypt analysis. So wherever you go, the first and foremost important of shows algorithm is on the cryptography. That is the encryption and the decryption. How you do it. And the next algorithm, because the next frequently heard algorithm in quantum world is Grover's algorithm. So normally in the Grover's algorithm, we actually try to solve an optimization problems. So in the beginning, we said optimization problems should be solved. Example, I will tell you. You are, people now also work on the fleet managements and everything. Yeah. And, the system can predict the system actually can predict how the data pattern can be. Example, you are a Amazon guy, and you want to deliver 100 products tomorrow. You have a target to deliver 100 products tomorrow, and you really want to give it to the driver that, what would be the first product to deliver, what would be the 100 product to deliver based on the traffic prediction for tomorrow on a particular area map. Yeah. So if that is the case, how you will do it? So example, I will just show you one video, small example. Uh, so this is something I'm working on a different thing, but I just wanted to show you, if at all you wanted to predict something. So these are some of the things that I have written. Okay, so now you see this picture. So here I have this is a sumo. This is a simulation of urban mobility. So this is actually the sumo is already an existing simulation concept, but on top of that, I have developed something. So I'm just showing something which I've developed for a different purpose. But why I've taken this to show you is you can understand. I can completely simulate everything into the real world. So here I can able to connect it to metaverse. I can able to see the simulation like all these things. What you see is like how the traffic it is. The small boxes is kind of like a fuel station, or you can take it as an electrical charging station. So you can actually see when the traffic is actually getting more, how the cars are getting occupied, and if the traffic, because I can actually simulate any graph. I can actually even put Coimbatore graph, I can put Chandigarh graph, I can put Chennai, Mumbai, whatever graph city map you want. I can upload the city map, I can set it up a toll gate, I can set it up the traffic lights, I can set it up the trafficking signals, and I can able to place the traffic the electric charging stations or fuel pumps or whatever it is. This is just, if you think of, if there is a electric charging station over there, if there is a traffic signal over there, if whether the car can able to get the proper charging station or not. Example, if you see the flow and everything, and slowly, as the traffic slowly gets peak, okay, as the traffic slowly gets into the peak, whatever you have seen, just imagine that as slowly the traffic is getting into the peak, whether the car can able to, are we able to handle so many data? Let's say I can able to make 10,000 cars in a city map, and I can able to simulate for 6 hours, and I can study that when the situation is like 10,000 cars is roaming around in a city, at some time, how a optimization has to be, how the decision has to be taken, where would be the traffic I would get blocked. And example, if you really think that if a vehicle is trying to find the nearest charging station, and there is a natural calamity, and suddenly due to the weather, I can introduce rain, and due to the weather a tree is falling down, and the nearest fuel station will become the farthest fuel station, and how the car begins, whether the car can reroute into the traffic. I'm just saying an example. It can be of anything. It can be of, again, as I've said, it can be of traffic optimization, it can be of fleet management. So whenever you want to take, I can give a driver the complete list that, hey, you want to deliver this product first. Then you go to this address. Then you go to this address. I can rank the 100 address predicting the traffic for tomorrow, so that my target for 100 product delivery per day If I'm an Amazon guy, achieved. I can give my product using quantum. I'm just saying a simple example. Of course, we will come to a different bigger examples, in the next sessions or something. But I'm just saying, trying to solve an optimization problem still exists. We still have optimization problems. We still have NP hard problems. We are not able to do it. Quantum algorithms can do it. And Grovers is specified for solving optimizations. And if you think of the, optimization, this is again, we exactly, apart from Grovers, we also have quantum approximate optimization algorithms, which can actually solve, smart city. If you look into that, it can actually find the near-term quantum devices. You really need to see how things will be. Example, if you really think a woman is trying to cross a road and a vehicle is coming, and the information is actually going to the servers and it has to come back to the system and the vehicle has to stop. This is some intelligence we have provided, but let's say we are, sometimes we also badly hit. Why? Even people who are working on a CNN algorithm, because some people normally for any image optimization or image problem that we take, as I am from automotive industry, I'm talking more relatively to the automotive world. So example, if you see that if a vehicle is driving on the road at night time, and normally, you will have plenty of images. The system will actually take 1 lakh images for certain meters itself, trying to decide whether there is a hindrance, if at all you are driving on a hilly road at night, or if you are driving on a sunny day, on a daytime, very sunny, and due to some reflections from the sun, the system even today stumbles. Even we have seen Tesla vehicles failing. It is hitting the women crossing the road, or it takes a very bad decision. Why? Because even though we have plenty of information, we are not able to decide because of the optimization problems. That is because the chain up or the data, whatever it receives, it can't able to relate it. So it can't able to relate and get the answer on time. So the decision engine can't able to decide. But exactly this, for all these kind of optimization issues, we have a different algorithm called itself as approximate optimization algorithm, and it is of the third type. The fourth type is on the walk algorithm. Very interestingly, the walk algorithm is actually used for secure communications, especially for network routing. There is one problem. Interestingly, every edge, people who are working on edge AI or edge devices, who have taken up the research thing on the edge systems, on the edge side, they would have heard this terminology called as the dump problem. D-U-M-P, dump. What is a dump problem means? So whenever you are trying to get some information, you are not able to solve it on time. See, the curse of edge devices is, edge systems, edge devices have a very small memory. And that's why connecting edge with cloud becomes costly. Why? Because edge have a very small memory, and normally edge devices will be at, why it is called edge, it is at the client side solving, it is at the client side trying to take the decisions very fast. Your camera monitors, basically your monitor, all sensing devices, IoT sensing devices, most of the sensing devices are now coming up with the edge concept called as edge devices. And the intelligence is actually moved to the client side so that it takes decisions very fast instead of coming to the central system and getting back. Now the dumb problem is the system, but the problem is the edge devices have very small memory. It cannot able to solve certain things in a limited time. So what it happens is, the dumb problem is, it keeps on, the data is keep on dumping. The system is not able to decide based on the dump it has received. So it is simply, it is eliminating or rejecting, and due to that, a beautiful information from the raw data is lost. We do not know which, because the system is simply eliminating. It says that I'm already full. I can't fill you up. My cup is already full. So it's keep on eliminating the stuff, and and sometimes on the edge devices lose out the important information. And this is again an important topic for many researchers. That is moving the AI models or edge devices. How you can actually make the edge devices process the information at a very good pace. So that is where this Walker's algorithm is used, because it is used for network routing. Because in network routing, you are in Karunya University and you have a signal in Karunya University and you want to come to the core or a railway station or something, and you are not in between, you have 4 to 5 signals or anything, or network towers or something. Maybe we will take signals. If the system is not able to if the edge machine is not able to provide the information about the traffic from Karan University to the next point station, this is called dumb problem, and the decision engine will fail. It will not able to decide anything, with more accuracy. So this is where this walk algorithm comes into the picture. It helps. Yeah. And the HHL algorithm, it's actually, the HHL algorithm is used, for a data processing and analytics. Especially when you want to process a big data, and if you want to chain up something, you want to link something, you want to showcase on a big data problems, that how data is chained up, how the data is actually flowing from A to B, B to C, C to D, in a graphical theory representation, in a graphical representation. This algorithm is actually used for an effective chain up, and it plays a crucial role in optimization and simulation, especially in simulation, because HHL algorithm can able to chain point A to B, B to C, C to D, so that it can actually able to predict or simulate something, that if something is happening on point B, if some B is getting disturbed, how C and D will get disturbed, how C and D will get impacted. So that's why HHL algorithm is not only used in optimization, but also effectively in simulation mode. So before I close, on the different types of algorithm, Shor's algorithm, especially on the cyber security, because using the Shor's algorithm, people can break encryption. So we have to use it as an antidote. Yeah. And Grover's algorithm is especially used on the optimization problems, especially, on the searching thing. If you want to make an effective search very fast, Grover's algorithm is used, and optimization algorithms we have seen for the optimization purpose. Walker's algorithm is for, network routing, especially to solve the dump problem and issues. And HHL algorithm is especially for optimization and simulation. So these are some of the basic 5 different types of algorithm that we have, with respect to the quantum. Not only, this is not like quantum has only 5, but these are some of the basic algorithms that quantum uses as a base to address different use cases. Okay, we talk different things. We talk on different problems that we say, because now we are actually saying that we have GenAI and everything. GenAI can solve anything. So, but there are. I just wanted to highlight on where quantum will be so effective. Why quantum is still needed. Because even with the GenAI technologies, it is not a one-stop solution. We have still some issues. I have 4 important problems to discuss, and the first problem is on, computations are becoming expensive. Yes, we are spending because of high dimensional space. Because parallelism for high dimensional or expensive. If you want to do parallel operations, because GenAI can able to perform sequentially, but if you want to do something in parallel, high dimensional, for the need for high dimensional space is there, that it directly proportionate to the expensive thing, cost and expense. It's very costly. It's like, as I've told you already, when you want to solve a maze, it is solvable even today with GenAI one at a time, but not simultaneously. So for that, when you use high cloud machines, it's too costly, because a normal cloud machine with 12 GPUs or 8 GPU or something, it costs around 2,000 euros. That is 1,60,000, or not 1,80,000 per month per system. So because we are spending crores and crores on machines, on especially on cloud, Amazon, Azure, things like that. So it becomes costly. Second problem is, it's very interesting. I like this very much. Even today, every house has this issue. That is, we might be having document of very old. We might be having some our ancestral property document. I mean, to be specific, we are having a property document which is of very old, and even today, GenAI or any technology is not able to solve it because GenAI can able to give a summary of only one page. Let's example, there might be a long story and in the fourth page or 10th page, some reference will be there, like it is related to the first page. But GenAI can able to do a summary of every single page only. It is not able to link, it cannot able to understand, it cannot able to link today. What is said on the 10th page is obviously related to the first page. So this is true. Even today in lawyer's office, every team is there. When we provide our property document, if they want to check on, is there any issues, is there, if they wanted to understand the property document, which is of 30 pages or 20 pages, they take time. They take 10 days or 20 days, but so still the issue exists. We are not able to achieve something good even with the existing GenAI technologies, and we depend upon quantum technologies to come and pitch in. Why? Because quantum can able to address many things simultaneously, not sequentially. And problem 3 is very interesting on the image analysis. Image analysis on the medical field is very much troublesome. Today, every college, even when I go to Viva, I mean, as an external examiner, I see lot of projects on the medical image analysis. People are trying to use some sensors. People are trying to predict something on the if even the brain sensors, brain waves. People are analyzing brain waves and trying to create a when the patient is on the panicking situation, it will give an alarm to the nurse station or something. Likewise many things. But if you analyze a tumor, people are not taking AI for granted in one field, that is nothing but our healthcare field, that is on the medical field. Because the Gen AI is not able to distinguish your brain tumor from normal tissues. It has issues with the image analysis. We are talking about CNN, what else? We have Huff Transform, we have OpenCV, many things are there. Okay, these are all old things, and many new things have come up with neural networks and everything's introducing more hidden layers, analyzing the image back and forth, fine. But still, system, even with Gen AI or explainable AI, people are not able to distinguish the brain tumor from a normal human tissues. That's why we are using the current technology as a reference diagnosis, not as a definite diagnosis. So something, why the system still not able to connect, the system is still not able to compress the data, take a decision in a short time, because the limits are crossing. The system is coming and settling down with a one particular answer within the stipulated time. So that's why it goes wrong in the medical field, and we still have a problem with the explainability is missing. Why it has taken such a decision? The system is not able to generate the reason in the medical field. And the final problem that I want to highlight, why we need quantum principles, quantum algorithms, so quick, is, I don't want to explain this. You ask by seeing the names, deep fakes. Even today, this is a recent info that I've read in the news evening, that our prime minister have requested for, in the AI conference, he has requested to have a proper solution for deep fakes, and especially for data privacy. Because as I've told you, the hackers are coming up with more powerful. The hackers are now coming up with more, in a humanized form. We don't know whether it is now. Earlier days, we were able to identify whether it is a hacker or not, but nowadays we were not able to identify whether it is a hacker or not. And even nowadays, we are also receiving video calls from the hackers. So data privacy and the data threat is there. So even with, as a technology advancement, we need so powerful, not Gen AI, but we need so powerful thing even beyond Gen AI, that we need a harder weapon to protect or to identify or to protect ourselves on this problem 4. But apart from problem 4, on the image analysis, on even on the nuances, smallest nuances, understanding what anything is about to mean, and even on the expense thing, on, I mean, especially on the parallelism, on simultaneous working, everything, we still are struggling. One thing is we are good with only, we are progressing very well on chat GPTs, deep seek, everything fine. But but when you really think on non-software uh, stuff, we have a serious problem in hand that is approaching us in the upcoming years. The only solution what we have is with quantum principles, where the quantum principles are applied through quantum algorithms, and we need to explore more, we need to research more. Utilizing that, we have the best chance to address some of the important problems what we have discussed. So that's what we have discussed. And in spite of discussing all these things, we have challenges, I accept. The one easiest challenge what we everyone knows is on the cost. Even today, because I have quantum machines in my lab, in my office, and it costs normal, a small machine, quantum machine cost 5 to 6 lakhs, small machines, and it has many things. If you look into the challenges, building stable quantum computers, you know, it's a really still a challenge, because quantum machines are not stable, because it's a new niche technology that is upcoming but very fast. And we don't have any error correction techniques, and that's why we have tunneling concept. We have tunneling concept, but we don't have a proper error correction techniques, and we need to scale up a large number of qubits. Now when you take people are normally working on, the qubit size is different. Normally if you take 2 qubits, 3 qubits size, that means you can represent anything in 3 different state at a time, on 2 different state. You can just think on that. So if even if at all you want to try something on a kind of like, you want to simulate something in your, in our own machine, we can do it. But the problem with our own laptop is, my machine is of 64 GB. It's a performance machine. My laptop is of 64 GB RAM, but but the RAM what I'm having is on the procured machine is different. But scaling up to a large number of qubits is still a challenge, because our laptop can't withstand. When you try to increase the number of bits, 2 bit, 3 bit, 4 bit, but if you cross more than 10 bit, our laptop will start to. But then we need a proper machine, and and we need a proper error correction techniques, and we need to build a stable quantum machine, because the concepts are new. It's a niche one, so we obviously have some challenges and limitations. We have decoherence, that is, if we have a lot of noise disturbance, due to the noise disturbances in the data, when the quantum algorithms deal with, we need to be very careful in correcting the noises. Otherwise what will happen is the quantum state will get altered. To put it in simple words, no, I don't want to get into detail of that, but again, it's a ocean. To put it in simple words, decoherence is, if there is any disturbance in the quantum machine, the quantum state will alter, and it will produce a false an inaccurate output. And we have a limited applications. We don't have, because quantum is not a very frequent technology that is available and applicable to different applications. So we have very limited applications. We today, working on the universe, identifying the planets. On the medical field, we have, the applications on the medical field, especially on the drug discovery, not at present. So then we have a limited applications. We don't have, a wide variety of applications where quantum is applied now, but for now. But that is still a limitation to what we have in our hand today. And cooling requirements, yes. Quantum machines will produce a lot of heat. And you will not believe, I have visited one of the, in Germany, I have visited one of the quantum labs of IBM, and tremendous heat. They have, they will allow you for 15 to 20 minutes to work on quantum machines, to work on 128 qubits. They will allow us to work on 128 qubits. And the amount of heat it is generating is tremendous. So we need better mechanism, because when we make it reality, when we make this quantum computers in real applicable for different applications, this cooling requirement has to be definitely taken care, because the processing power involved is high, and due to that heat is generated. So, but we it is still a challenge for us today on the cooling requirements and algorithm development. So we have a challenge in understanding the algorithms, you know. So we have a challenge. That's why we have dealt with the basic 5 different kinds of algorithms: Grover, Shows, HHL, walk algorithm, optimization algorithms, and all. But these are some of the basics. But beyond that, algorithm development to address, algorithm development to integrate with the classical computers, not only on the quantum computers. When you want to integrate certain things on the classical computers, the algorithm development pose a challenge and limitations we have. And finally, on the security concerns, because as I've told, as we progress with the development of the algorithm, when you deploy something, again, sharing of data at a very faster pace, security concern also comes into the picture of the data theft being involved. Some of the applications, I wanted to just highlight, but that we will discuss in our next session with a small break. But these are some of the things that current applications, what we are focusing, we will discuss. But current applications, we have the drug discovery. As I was telling you, the drug discovery is a main thing, and material science. Because why we are interestingly, there is a geopolitical reason why we are afraid with Taiwan. Whenever there is a not afraid with Taiwan, when China is have an issue with Taiwan, why we are afraid is 85% of the semiconductor material is coming from Taiwan. Okay, so now when we are looking for an alternative thing to a semiconductor or any material, you need to work on a different attributes. You need to do a lot of permutation and combinations. And for material science, that is discovering a new material. Like I said, using quantum sensing, IIT Madras is working on discovering the artificial diamond. We are trying to do something artificially. So on a material science, on an improved properties, who knows? We can come up with the artificial diamond with rather than with more property or attributes, improved properties than being a natural one. So material science discovery, we may work, it may help us to discover a cheaper materials, but it can withstand something. So material science discovery, financial modeling, on optimizing investment strategies and risk management. Nowadays, basically normally for stock exchanges, people use long short-term memory, LSTM. People are using it, and some people are also working on some researches on LSTM, how to predict the share market, when to sell the stocks, when to buy the stocks. There are like almost this technology, this machine learning being involved in stock market exchange for now more than 20 years, but still people are every day coming up with new algorithms. So financial modeling also, in certain financial modeling, even whenever you want to do a financial modeling for a whole country, then you need a quantum principles or algorithms to design whatever you want. I'm just an example. And artificial intelligence, of course, more powerful and efficient AI algorithms. When AI is powered with quantum. There is an article in April 2024. I forgot the name of the article. It is in IEEE, where an author has started writing an article saying that normal Gen AI machine cannot think. Can a quantum AI machine can think? So that means he has very well forecasted that the quantum AI can come very closer to human in a human form, in a humanist form. So artificial AI powered with quantum is going to be very, 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 very powerful and efficient algorithms will be coming up. On the final slide for the session 1, I just wanted to convey on impact on society, the road ahead. Okay, we have beautiful niche technology, niche applications on the quantum computing stuff that is there. But where all, what is the road ahead? Transformation of industries. It is disrupting slowly. It will disrupt, or already it has slowly disrupted, but we are not seeing it. Like how Gen AI is now having a disruption in every field. So quantum will have a big. It still it people prediction is it will still have an impact of 4x power of impact with quantum in 3 to 4 years, disrupting various sectors with innovative solutions and unlocking new frontiers in research and understanding. Because whatever scenario that has not been discovered on everything, quantum will discover, because it can work on unimaginable speed. that it is used, and ethical considerations. And of course we are working on, but we are also working on to understand the people difficulty, because whenever you are bringing on something very powerful and very niche, how people are getting affected. So we need to be also work on the ethical considerations. Example, on the data privacy thing that we were discussing, how a security key can be broken in a very shorter thing, and how a data can be easily stolen, of people's information can be easily stolen, how quantum can be able to replicate. So all these are all comes with a threat, but on the ethical considerations, it has to be considered on the road ahead of quantum computer or computing that is coming up on the society. So with that, we I hope we have I've just explained on what I foresee on my interactions with the experts and things, and what quantum computing is getting ready, what is the opportunity with the research, and what is the impact, on what are all things that we can forecast, what all the different use things stuffs that is upcoming, but and also the basic setup of what we need to know on the gates and the circuits and the different algorithms, as a part of quantum, exploration on the quantum computing stuff for the first session. And I think we have some questions. Sorry.
Sir,
Yeah.
shall I post the questions? Shall I read?
Yes, ma'am. Yeah.
Questions are posted by the participants.
Okay.
One of the questions is classical computers use parallel processing by
Yeah.
running multiple computations simultaneously on different processor. In contrast, quantum computers leverage quantum parallelism using
Yeah.
superposition.
Yeah.
However, measuring a quantum state collapses it to a single outcome. How does a quantum algorithm like Groover search use quantum parallelism to speed up this
Okay.
measurement?
Okay, so we have one concept called as decomp model. So basically, entanglement, or I mean, even with respect to the superposition, we have some approaches. That is, using the gates in certain things, we need to strengthen the quantum circuit with the combination of the gates, that the poly gates. And but rather than poly gates, people prefer controlled not gate. And but even in control not gate, there is one concept called as quantum as the terminology entanglement. There is one concept from tensor network called as entangler. For you to experience this collapse, for you to prevent this collapse, there is a concept called as entangler. And apart from entangler, you also have one more concept called as decomp. So dense decomp. Normally, whenever there is, you have a quantum states to prevent it into collapse. To put it in simple, let's say you have a dense layer as an input layer, output layer, and you have two dense layer inserted in between. And this dense decomp is a concept from tensor network. Just have a try. That will prevent the collapse of the quantum states. If there is a disturbance collapsing the states on the classical machines, it will prevent. And there is an entangler concept also within the same package. So upon your requirement, upon your size of the data set, because these normally do a data compression and on the quantum states and work. So this could be one of the things to try and check. Yeah, one solutions. Yeah. No, because you have actually mentioned the very right algorithm, that is Grover's. Yes, no doubt that you have mentioned the proper algorithm. But in Grover's, for the same problem, we have a small solution from tensor network that which I was discussing now, that could be tried.
So the next question is, what are the components or electronic devices required to implement the quantum circuit?
Again, it's based on your requirement. I know as a beginner. Okay, as a beginner. Okay, what hardware component? Okay. So it's again based on some of the you need basically, because if you really look into that, how to start. Even to try out in your local machine, Qiskit, QIS, KIT, Qiskit, CIRC, CIRQ, all these packages, you even when you try to use a PyCharm edition, you need a licensed community edition rather than, you need a professional edition rather than a community edition to try out these packages. But on hardware, this is just a software ID stuff. What I'm trying to tell you, I think it costs around 20 euros. That is 1,600. No. 1,600 rupees per month if you are working on quantum stuff. But on the hardware, you have a quantum simulation systems that is available. Even in Amazon, if you now search the cost, the number of GPUs, how much you need for a tryout, because it's again based on the qubits, how much qubits that you want. Again, the qubit will point out to what is the application that you are trying to solve. Again, to limit the basic tryout in, let's say I wanted to use some 100 qubits, yeah, or some 50 qubits to address a decent a problem, but using quantum principles. Then for that, I can even give you a link, a sample link, where there is a company, I've really forgot, that allows you to customize the machine. Then they will ship you the machine, and average cost of the machine will range from 1,70,000 to 3 lakh. But again, if you are working for an organization, but if the organization is ready to buy you, then the range goes to 5,50,000 to 6 lakh. But for a basic machine, we can get it from even 1,70,000 customizable till 3 lakh. And but I will share you the link of that, where you can customize and place the order. So
the next question is, since quantum computers rely on probabilistic computation, how can they be effectively utilized in stock market forecasting?
okay.
And yeah.
Sorry, ma'am. Quantum era completely replaced. Okay. Quantum era completely replaced classic computers. Stock market forecasting, long short-term memory. I can understand your question. Actually, it's very nice. Actually, because nowadays stock market prediction, long short-term memory is used, but the problem with the thing is how much data that you deal with, because how much prediction power that you deal with. So for that, quantum computers or quantum algorithms we can use. Then the question is, will quantum era completely replace classical computers? Slowly, again, it's based on the cost, because now we are not able to predict how much cost when a full-fledged quantum computer come into existence in 3.5 or 4.5 years. But 4.5 years is too long. What I'm also thinking is it may come into existence in 3 to 4 years. It's a horizontal topic. One thing is, quantum era completely replace based on the cost. I think it will take some time to replace completely, but classical and quantum will coexist parallelly for some time. Is what, because definitely quantum will never able to come down to the cost of normal classical machine, because nowadays normal classical machines comes around like 1 lakh, 1,10,000 and all. But the basic quantum machines, comes into the two. But one point is, it will not completely replace. Rather, there is one startup called as D-Wave Systems, D-Wave Systems. And there is one more startup in the European side called as Zapata AI. So what these two fellows are cleverly realized is, they are actually providing the quantum services as cloud services. It's like pay per use. So people are trying to use that as a, slowly, example, I'm a research guy, maybe I'm working in an institution. I wanted to use the cloud services, and they are using the D-Wave services, where the D-Wave systems, the D-Wave, that is a startup company they are the leading startup company in quantum. So they are trying to provide it everything as a service. Maybe rather than replacing completely the classical machines with the quantum machines, people might also interested to use the quantum services as a cloud services. So pay per use, maybe. Yeah.
The next question is, how quantum computing can be useful for IoT device? Quantum computing can be useful for IoT.
Okay, so IoT device, basically, why I'm saying with IoT devices, the problem with the IoT devices, see, normally in agriculture, I'm just saying an example in agriculture. In agriculture, what is happening? I think slowly our technology community is actually also turning its face towards agriculture also. So normally in agriculture, what is happening is, even I myself also have a patent algorithm to identify the crop cultivation. So what happens is, normally we have IoT devices. We measure the length of the crop, and what happens is, we know the type of the crop, how much yield it will do, and if there is a disease infected, What we are doing is we are actually connecting with the cloud, and we are actually, the system is actually, the intelligence is actually checking that whatever the, the disease the plant has, whether we have a solution in the cloud, from around the globally, whether we have a solution, we get the solution, we provide it to the farmer, we provide it to the user, that hey, whatever you have, you know whatever the crop that you have done, as per the prediction, it will not yield, but instead it has, because it has some disease, and you need to give these pesticides, and this is the solution. Fine. Now here is where IoT devices, rather than, also when it is used as a sensor, as a we have cameras that we have within us, we have some intruder prediction, something we are also having. Now what is happening is, that is what I was also discussing with the dumb problem. Now problem is, when so many attributes are involved, normally we are easily we are starting with 60 point. Okay, I don't want to mention the decimal numbers. We are starting with the 60 million parameters. 60 million parameters nowadays and all very common. So 60 million parameter probability, when we are analyzing it, and when we wanted to analyze 60 million parameters input, and the probability has to be calculated in a very short time, IoT sensors are stumbling. And moreover, the IoT sensors, even in automotive mobility market, I mean the automotive world, we are stumbling, because the IoT sensors is not able to process quick information. Why? The dimensionality vector, the vector, we were not able to chain up, nor the vector size we are not able to reduce. So because of the dimensionality vector reduction, because of the semantic chain up, we were not able to do it, because the current thing, we were not able to understand the smallest nuances, like the problem what I've discussed with the documentation and all. We were not able to properly chain up, we were not able to reduce the vector size. So why? Because, I mean, you will not believe. One of the colleagues, one of the participants here asked, I also told, try to use from the tensor network entangler and dense decomp model. The dense decomp model will try to reduce the parameters. Let's say if you have 25 lakh parameters, it will try to reduce it to 8 lakh or something, and the other entangler may try to reduce it to 3 lakh. So because of these concepts, we were able to reduce the dimensions, and because of the dimensionality reduction, but the same chain up is done using the entanglement concept, and we were able to achieve the decisions very fast. So with respect to the IoT, wherever it is involved, any prediction using the IoT devices, it can be in the car, it can be as a as a sensor device, it can able to decide everything very fast. So that is the advantage we have with quantum stuff on the IoT side.
Sir, the next question is, can you please suggest some simulator for quantum computing for medical image analysis?
Okay. Simulator. Okay. A very interesting question for the medical image analysis. One thing is, there are no proper general simulator, because we all know, because everyone now would have touched the AI in some other form. If you can't able to get a data set of a medical thing easily, because you need to get approvals, and because if you want to get it properly, and simulator on the medical image analysis, there is no proper. Okay, there is one. I don't think it is from D-Wave or Zapata AI or from someone, that they are providing you to try out with licensing format. Yes, with licensing format, they are asking you to provide. You can actually try to work your algorithms on a medical data in a cloud services. It's pay per use. It's on the licensing mode, but I will just get you the link. Maybe I'll pass it down in some time, if it is possible before the session ends, the next session ends, or I will give you. There are something that you can actually simulate. Azure services is also available. Azure services is also available. You can get the Azure services. You can try to simulate a medical image, or it should be from one of the startups, D-Wave or Zapata AI, that they provide the cloud services where you can able to simulate the medical data set or something. What algorithm do you have on the image side? You can try it out. You can upload the image. You can try. You can implement. It's like a plug and play. It's like ML ops. If someone would have used ML ops you would have already known. In MLOps framework, you can just plug and play the different algorithms and you can really test your uploaded image. Likewise, I don't recollect my mind is just thinking on what is a startup which is providing. But that startup will ask you to upload the images, of course, after getting some license. Then you can actually use kind of like a plug and play. You can apply the algorithm on the medical images and see how simulating the quantum, your results are there, and you can take the results and compare with your own neural networks comparison or CNN comparison or whatever it is. But I will just check and give you the link.
So the next question is, are there any estimation as to when quantum computing becomes a major force in the industry?
4.5 years. That is definitely. It is not. It is actually as we speak. It is a Horizon 3 topic. To be more precise, because I have spoken to one of the father of quantum computing in Renningen in Germany. So he told me exactly. He's Dr. Stefan. He told me exactly. It is going to be exactly. If you ask me so precise, it is going to be 4.5 years from today. It is going to have an impact. But the industries are pushing. Industries does not want to wait for, because they have invested more. So industries are trying to push. Is there some other way that the quantum computing come into existence by creating an easier coolant, each and everything, especially BMW, I think, no, especially Daimler, that is the Mercedes group company, is pushing very hard with these startups. They are working very hard with these startups, trying to bring something on the quantum. They wanted to be up speed. They does not want to wait till 4.5 years or 4 years. They wanted to try to bring it very fast. So they are also, you have to remember, Daimler is the very first company. They are combining with IBM and trying to bring the quantum machines very fast for their own purpose. Why? They need to have an optimization for a material science, because see, nowadays they are trying to. There is a big competition on the car market. Who can able to produce the car at a cheaper rate? Okay, so the Mercedes and everything, they want to lead the world, and they are trying to combine with IBM, and they wanted to, do a material science investigation, and they want this quantum computers to be existing very fast. So things are going, but at present, 4.5 years, people are working to bring it before that also.
Sir, this is the last question. Is there
Yeah.
any application of quantum technology in routing in wireless network?
Currently, no. Currently, no. But government is, because see, there is a nice argument happened between 5G and quantum. So people were arguing, because now we have 5G in our mobile, and people were arguing that there was one simple question put forward: is, does 5G is not enough to make a wireless network routing? So suddenly, everyone, a simple question from a simple researcher stumbled everyone. So why you need a quantum? Why a government of India has to invest on 6,000 crores on quantum when you have a 5G network in a wireless thing? Can't a 5G can't able to, does 5G is it very fast? Where 5G investment in 5G is very cost effective compared to quantum, but there are security wise purpose, routing and everything. They have also replied back, fighting back, saying that quantum technology has a plenty of upper hand when compared to the existing 5G network. But in routing in wireless network, currently, according to my knowledge, 5G is there and routing, everything is exploration is happening. Quantum technology research is going on, but we don't have a live application as of now.
Sir, one more question. Doctors are accepting the AI-based result in healthcare. While we check the BP in mobile,
Okay.
use the AI tool. But doctors are not accepted it is because it's showing not accurate result. Please need your explanation. AI result is not is correct or not?
AI result, the problem is, I don't know to tell the name of the product. Let's say there is an X product that is already in the market, where if you insert your finger in the product, you will come to know the iron level. Yes, that is a correct. Iron level. Iron level means how much the iron level. Normally, the iron level has to be between 14 or 15, I guess. I don't know the extension. It's like 14 or 15. It has to be in the double digit. But normal iron level in our human body has to be between like 13 to 16. They have some range. But the problem with that machine, a popular machine, they have released that saying that because to identify your iron level, you need to do a normal blood test, and along with the blood test, normally, we will identify how much salt content we have, how much iron content we have, how much hemoglobin, everything it will come in the test result. But normally, even today, what happens is when you give a blood test, you will normally have a result. Normally, we have a blood test machine in our home. You just pinch that in your skin, and you will come to know your sugar level in some seconds. That's fine. But if you really want to know your hemoglobin count, iron count, and everything, you are trying to give a test to the laboratory, and you are waiting for like 1.5 hours. You get a message in the mobile that what is your complete report is there. Now, speeding up to that, there is a recent device that we have, where when you just give your finger, when you give your, pointing finger, if you're inserting that into the device, it will tell you the iron level in seconds. But now people have easily proven that, and when it got introduced, it shook the laboratories. They were, because every people can easily identify their iron level, because that is very much important for the pregnancy women. Now what happens is, now that has been proven wrong, and again we are going back with AI in context of health. That is because, why? Because the smallest nuances, that's what I've told. The smallest nuances means the smallest details we are missing, because they tell, especially with respect to image analysis. That's why I told. Still, image analysis, we are using AI as a reference diagnosis, not as a definite diagnosis, because we were not able to chain up. We were not able to chain up the smallest nuances. Even with Gen AI, we are not able to succeed with respect to the image, and that is a in health field. It's very easily visible that Gen AI is not good. If I take Gen AI, it's not good. With respect to the image analysis. But when everyone has that opinion. But even when you take the automobile, as I'm coming from the automobile background, when you take a car and when you try to analyze an image, when you try to predict something, we still having a failure with respect to the image analysis, even using Gen AI, because Gen AI cannot able to handle so many attributes. Why? Because Gen AI works sequentially. Not only Gen AI, any technology, but recently, I'm taking the Gen AI as the recent one because it is now the hot topic. Gen AI also can work sequentially, where the attribute size is, we are not able to reduce. We have a problem with attribute size, dimensionality reduction. We have problem in, we were not able to work simultaneously. And all these things are expected to solve with quantum. That's why we are moving so fast with respect to the image analysis with quantum, because the only field that has not so much concord with the AI is healthcare field. So yeah, you're right. I mean, the question is, the answer to this is yes. AI tool experiments results are not expected, because it is still, we have not gained confidence with AI in healthcare field. And yeah, so the last one, programming language. Programming language. It's a combination. Some simulation for some. If at all you are going for simulation, Python would be the best. And if at all you wanted to have a quick try, Python would be the best one to try, because Python have all inbuilt packages, the Qiskit, the Circ, and if at all you want to use tensor network, everything is, we know, Python, plug and play. You just download the package, use it. You don't need to be a master in knowing those algorithms, because everything is provided as a package. But there is one more stream that is also running to use C#. C# provides answers very well during simulation. If at all you are working on the simulation world, if your problem statement is on the simulation world, better to use C#. No, I'm not saying Python is bad. C# is a little bit better than Python in terms of simulation. But if at all you are trying to use some other things for optimization purpose, for searching things and all, Python is good.
Thank you, sir. Now we are at the end of this session one. Thank you, sir, for providing lot of insights into the real world scenario and sharing the research problems for the academic as well as to the research community to work further. Really, it is an interesting session, and we are eager to know further. So I request all the participants to come after 10 minutes quick break. Thank you so
Yeah.
much, sir, for addressing all the
So,
questions of our participants. I hope our participants are happy with your session. Thank you, sir. Thank you, sir.
okay.
We'll join
Okay.
after 10 minutes. Okay, sir.
We will be back in 10 minutes. Okay.
Yes, yes, yes. Participants, the session is about to start. Kindly stay back. Sir, you can start the session.
Okay, yeah. So, hello all, welcome back. So, I know it's difficult, anyway, the second session is going to be very, I think I will try to have to a decent time. I know it's 8 p.m. already, and thank you for staying with us, patiently hearing my thoughts in quantum computing. Yeah, okay. So, I will share my screen. So I think this session, I think it's going to be really. I think it's mainly we will talk about um, quantum computing. I mean, in quantum computing, what are the applications, especially how it is slowly getting implemented, how we are trying to make it reality. How, because many of our friends, professors, and everyone have asked, like, okay, when we can get quantum, when is it expected? Yeah. So slowly we will discuss on that, but predominantly on the applications, where we are looking into it, beyond whatever we have discussed in the previous sessions. In particularly in focused, we will discuss on what where we are applying. Yeah, but just on a small thing, even for this applications and all, I have prepared a small AI video using prompt engineering, and I'll just wanted to play that. I know there is some issue with my lab in giving you the audio in a full sound, but please bear with me. So I will share my screen once again. I will stop and share this video again. Quantum computing stands at the forefront. Okay. Okay. I'm sharing my screen again. Yeah. So you can actually now see that, and for the audio, so sorry, please bear with me. Quantum computing stands at the forefront of technological innovation. By harnessing the power of quantum, personal encryption methods rely on the complexity of mathematical. However, problems exponentially faster than classical computers, rendering currently computers can simulate and much more efficiently than current methods. This capability for diseases lives and reducing healthcare costs. Optimization, finance, and supply chain, consumption, and improving efficiency. And finance, portfolio at unprecedented speed. Quantum machines can lead across various from healthcare to see, its potential to disrupt and innovate is immense. The future promises a world where quantum can redefine solving and opening new. Okay, I think it has started from the beginning. But basically, if you see from cryptography, from drug discovery, healthcare, logistics management, everywhere, quantum is going to come And like our friends have asked, it is going to impact. It is going to impact everywhere. And yes, now I will share my screen. Um, okay. Okay. So now quantum computing, it's everywhere. It is going to come everywhere. Research on the way. And but one more thing is, for the as a researchers like us, and like you, and it's a tremendous opportunity. So whoever is have started quantum, and I think your phd is going to have a great value, because when you are completing if you have started your phd just now, and you are one among the expected guys, because when the market is able to make its availability in 3 to 3.5 years or 4 years, and you are one among the demanded persons. Yeah. And even we were discussing quantum computing implementations. What are all the steps that the industry is taking? The industry is actually taking steps, to make it like, as we have told you, the current challenge what we have is to make the quantum machines work on the room temperature. Sorry, yeah, because it needs a higher coolant, it demands the coolant machines also to cool down the quantum computer. And we have error correction methods. We don't have a proper error correction methods. We have gate operations. As now, when we discuss in the second sessions, I think we are also a little bit comfortable on talking gate, circuit, because I think we discussed enough in the first sessions. So the companies wanted to develop quantum computers. They does not want to wait for, like, 4 years, 5 years and all. They wanted fast, very fast. And very interestingly, if you look into this, one second, ma'am, you can able to see this other screen, right? Or doesn't. I mean, the YouTube. Now I'm trying to open a YouTube.
Yes, sir. YouTube
You can able
page.
to see, right? Okay.
Yes.
So NVIDIA develops a metaverse. You need to really see this. So this is kind of like world's first virtual factory. Why? Okay. Why we are going is, I will just mute this YouTube. I will explain. If you look into this YouTube, yeah, if you see this video, you can actually see BMW. I already told BMW is with everyone now. With NVIDIA, with IBM. They want something very fast with quantum. Okay. And someone has asked, okay, quantum with healthcare is not existing, and slowly these guys are using minimal level, but as a first step to have an impact of quantum, these guys have developed. Maybe you can also Google it. BMW and NVIDIA develops an omniverse virtual factory. What they are trying to do is, they are trying to simulate everything. So this CEO and the member of the board member of BMW talks like, they wanted to show something. If I pull that, everyone is in the meeting room, and one person explains that to the boss, that if the factory is set up with 4 different machines, with how much distance, and instead, you can see this, you can really observe this. If you see this, virtually they are deciding how you can actually see the power. See, virtually they are deciding, when you locate this machine, if you put this machine, and they will be deciding, like, if I put another machine over here, whether it will hit the each robot will hit or not. If you look into this, you can actually see here, as the video goes, they are trying to position the robot hand. They are just taking that a component, they're just bringing in another component, they're actually inserting it and trying to see virtually that if I place with this distance, every robot will work or not. And in a particular square area, every robot will work. And because BMW is the very first company that produces, every minute it produces one car, every minute. So they are automating everything. And when they want to have everything as a metaverse, as a metaverse. So, as a metaverse, they really wanted something to be a super power that can actually, because you are trying to decide something on the go, because you are trying to pull a robotic hand virtually and trying to place it in another place and see whether if I place this robot on an other place, whether it will be whether I will have an impact or not, and if I and whether the robot can able to function without any hustle, whether the robot by placing the robot hand strategically in these positions, whether my production of car, instead of 1 minute every car I can produce in 45 seconds the same car, 15-second production increase, great thing, 25% already improved. They are trying to design, they can able to manually dynamically, they can able to you know make things move, and there should be an intelligence behind the screen trying to tell when you try to alter different because when you try to move something or when you try to place something, again you are introducing a whole world of new parameters you are trying to bring in, where the behind the screen and the intelligence has to see that whether if there is a new 1 lakh parameters, when you place a new robotic hand is coming into the picture, the other robotic hand should not get affected. So it simulates very fast, and it produces result because everyone is on the call. It can't keep on loading. It is spontaneously, it is producing. So now what these fellows are doing is, this BMW guys are doing is, they are combining with NVIDIA, and they have set up a omniverse platform for them to decide, for them to do any strategic decisions, everything on the call. So just behind the screen, they are slowly, NVIDIA is trying to have different hardwares. NVIDIA is trying to produce a higher GPUs, different hardwares, different graphical, chips. So there are concepts like chiplets, like chiclets, there are chiplets and everything. Okay, that's a different world. They are trying to give it, and they are trying to use a pinch of quantum here in trying, because they wanted to give a simulation, because the decision engine wants to decide something dynamically. So that is this is one thing I wanted to show before we progress, because now you actually think on slowly, for the fleet management and everything, for decision making, for the fact, we are one thing we are actually missing out, everyone. I mean, generally, not speaking, I'm putting it in generally, we missed one game. We are focusing only on the software engineering life cycle. We are missing the other part. We are actually normally working on requirement analysis, use Gen AI, blah blah blah, test case generation, coding, copilot is there, everything is already there, but we are still focusing on the same Gen AI stuffs. We are trying to produce like, okay, extended version of, okay, my thing can analyze an image, my thing can analyze a text, my thing can analyze, generate test cases, for my thing can convert code from one platform, one language to another language. But one thing we are missing is there is another whole world that is non-software engineering life cycle. That is, manufacturing logistics. We have autonomous vehicle development. We have fleet management, logistics, and battery developers are there. EV manufacturers are there. Drug discovery, material science, whatnot. And those are the untapped areas where quantum is concentrating, and where it is also going to get applied predominantly, because quantum is not going to use on normal software engineering life cycle. No, we don't need it. We already have Gen AI, and we are already stepping into the world of explainable AI. So we need quantum, and we need a quantum power with AI for non-software engineering life cycle. That will be its first focus, because that is where the demand is for the quantum power to show. And with respect to that, people are working on trying to generate chips. NVIDIA, that's why I showed you. NVIDIA has already started to generate. They are already collaborating with BMW. BMW is leading the game. And they are already collaborating with the BMW. NVIDIA is also collaborating with BMW. They are trying to generate the chips which can actually have a lesser temperature, which can have an error handling techniques, better error handling techniques. And for that, one such sample is that Omniverse manufacturing plant, which they have opened very recently. which they have done very recently. Implementation levels, what they are, before we discuss interestingly on different applications, how we are getting implemented. There are three categories of implementation, because some people who, I don't know, because some people might be also on the embedded world, because here we have in the audience, we have a mixed population. So in the embedded world, if you really think, on the hardware side and the embedded world and all, we have different implementation levels for quantum: foundational level, corrected one, and fault tolerance. Okay. And again, not talking about the text, everyone hates this. So, but on just bringing on the crispy thing, on foundational levels, they are like, a car prototype, you know, they are like a car prototype. Um, you know, so they can run, it's like a foundational machines, because some of our friends have asked what kind of machines that I can use if I want to start working on quantum computing. These are the different categories. Basic quantum machines are there, reliable quantum computers are there, fully functional quantums are there. Because exactly like this, the link I will share with the ma'am. Maybe she can circulate. That link will provide you to customize, and it will charge you accordingly. That is, you can actually customize the basic quantum computer, or you can go for some more reliable quantum computers, or you can actually go for fully functional physical machine. I'm talking about physical machine procurement. Now, if you have a foundational basic quantum computer, yes, maybe I've already told you, 1,70,000 to 2.5 lakhs, 3 lakhs basic foundational machine you will get. And the computers at this level, basically they are small, very small, and they are you will not have a proper error handling techniques. The chips will not have a proper error handling techniques. You will have an nvidia in across all the three. Nvidia is there. Nvidia is, again, we all know they are leading it, and you have nvidia chips provided, and it will be very small. You can able to work on some small qubit kind of use cases. You can able to test and trial. Fine. If at all you are trying to produce an MVP, that is minimum viable product, foundational things, machines are good. And if you will go on a little bit error corrected, it is kind of like it is implemented. But what it will do is, again, as I'm from the automotive industry, I will always give it with respect to the car, or I will always prefer coin. So if you think it is kind of like a car prototype, it is just a prototype, kind of like a machine where you can just, normally when you try to develop a project, and if someone asks, hey, can you give me a prototype of your output, what normally we will do, we will never show a complete output. We will just show that this project can able to generate an output like this. If you give an input A, this will try to give an input B. Maybe if you try to give an input X, it will try to give an Y. We will just tell that A and B is a sample, X and Y will be done in a similar way. That is the foundational model. Error corrected is one level bigger. It is like adding safety features to car. It is like it will generate some errors. It is prone to errors, but you can able to work. Even there is some small errors in that machine, still that this machine will become little bit reliable than the foundational machine. It's like driving the adding safety features, like the last line says that you are adding a safety feature to a car, you can drive smoothly even if there is a small problem. Fine. Final machine is that is the costliest one, fault tolerant machine. And even on all these categories, you will get the service from Azure on all these three. Again, the cost will vary. If you look into the Azure, you will see that fault tolerant is like, I don't know, maybe 2 lakh per month. The charge is like, if you want to work on a fault tolerant machine provided as a service by Azure, 2 lakh something. But if you want to procure a decent fault tolerant machine, fully functional fault tolerant machine, it is 6 lakh. It comes closely to 5 lakh 50,000 to 6 lakh. So this will be a perfect machine. That is you are at the very basic stage, like you are trying to prove something like maybe with respect to blood test or something, or healthcare or anything, or an image analysis, something you are working, but you are trying to involve quantum and all, but you really need a full-time machine for you to work, and you wanted to procure something, then it's better to go with the fault tolerant, cost around 5.5 to 6 lakhs, a decent machine. So these are different implementation levels that is already there that you can use. either as a physical machine or as a service. Azure, every certain companies provide. Now, as I have already told, D-Wave systems also provide it as a service to you. It's pay-per use. How much you use, it is actually. You have to be careful while using pay-per-use, because you need to stop that machine. If you make the machine idle, you will be still charged. It is like some machines are like 1 hour 200 euros, 16,000 rupees, 18,000 rupees per hour. Some machines, if you want to try it out, but you will have the results of whatever you are trying it in our normal cloud machine. Whatever you are trying it for 24 hours or 48 hours, you will have the result in 1 hour. So that much power you have with that machine. But to use that machine, some people will charge 150 euros or 200 euros per hour. So you can use it like for 10 minutes and you can stop the machine and you can use it again. It is like per hour charge or something like that. But you need to be very careful. You can't keep it in idle fashion because you will still be charged. You have to stop the machine. Fine. Now, if you are going for challenges in implementation, some challenges we have already told. It is nothing new. We have stability issues. Qubit stability issues. We because of the external noisy disturbances. One of our friend have asked. Or one of the professor, sorry, to use the word. I mean, one of the professor or researcher have asked, like, yes, very nice question. How, when it collapses, what you will do? Yes. So that is because we still have the stability issues. That's why we now and then we have every different tensor network, from starting from tensor network, Qiskit, Circ, everything produces different stability measures, to prevent them from collapsing, to prevent the state in becoming collapsing. And the right thing is fragile qubits, error correction. We have easily, we don't have a proper error correction techniques. So that is one of the challenge. And scalability thing. So the problem is, if you want to increase the qubits and you want to, deploy it with the increasing of the qubits, it's very challenging, especially people who are working on an automation field. And when you want to scale it for an automation where you have different, sorry to use that word because normally that is a word we use it in the, normally in the full stack development areas and all, people use it as a slave machines, master and slaves. Master and slave machines, they have this, on-prem machines and all, they will say it like on-prem machines. Cloud machines are cloud machines. The machines, what you have it in your own network, it is called as on-prem machines. So normally in on-prem machines, you will have one concept called as master and slave. A master will be there. It will allocate everything to a slave. Literally, that is the name that we give. But sorry if something is offending for anyone. It is like a master will give a work to one of the slave machines, and each and every work is given to different slave machines. So even in that, if people are trying to use this quantum concepts or quantum machines, if they have different quantum machines, and scalability is a really problem because each machine costs very high. And quantum decoherence is nothing but especially related to the noise that the quantum state can stumble. Okay. So, and hardware limitations. And that is what we have seen, that you need to customize the hardware. It is always, we have like normal physical machines. We do have some quantum machines. Okay. Even in Amazon right now, we have, they always quantum machines will end with named as tower, quantum tower, tower. They will name something, but normally they will use the fancy name as some tower. Quantum tower machines, quantum, from HP or not from HP, from I think from HP only, I guess. So they have different things. Even in Amazon, you can now Google. I mean, if you look into the Amazon also, you will have different quantum machine setup. If you ask for some they will be clearly told that it is for quantum simulation. It is for different purpose. They will mention. And in some Amazon sites, they will allow you to customize. If you want to replace it with different GPU, 24 GPU, 64 GPU, 24 GPU itself will come around it's costly. So normally you have hardware limitations to play around, unless until you know very clearly what you need. And the cooling requirement, as we discussed, we need a proper cooling mechanism for a quantum machines, because even if you, I think if you see a physical machines, it is not portable. It is not portable. It's not like our normal laptop that you can easily shift, or normal physical machines that we have. It is not portable. The portability issue is there because it is still a little bit wider in size, and you have cooling issues and lack of software and algorithm development. We don't have. Problem is, even if you go to IEEE Explore, and if you search, or even in Google Scholar or anything, if you search, quantum references are, it's good only, but it is not as good like when we do a normal search. Lack of softwares are there, lack of algorithms are there. The problem is, even when you develop a software, how you will integrate with quantum? How you know? Again, this point is related to with everything. If you try to develop a software or an algorithm, you need a better hardware machine to really test a full-fledged system, which is too costly. And this next one, what you see is a very interesting topic, that is hybrid integration with classical machines. Because recently they are trying to prove that even within classical machines, we are trying to achieve the quantum power with some algorithms, with some simulations. We are trying to integrate with the classical machines, and that's why one of our professor or a colleague here have asked, like, even in classical machines, if I want to shift something when it collapses, what I can do? Yes. So there is a challenge that is already mentioned by our, one of the participant. So that is there. That is a hybrid integration with classical is still a challenge. And error rate. We have spoken enough. Quantum gates are prone to errors, because when you want to use the quantum gates, you really need. Example, if you use a poly gate, polygate comes in 3 different flavors. You really need to know what to be combined. Because if you are developing a quantum circuit, see, normally quantum circuit is, again, I'm saying, like, it is a mixture of different quantum gates. A circuit is. And if you're trying to use, a poly X gate for a specific purpose, and you are trying to use a Hadamard H gate for a different purpose, and control not gate for a different purpose, errors, prone to errors. And how to handle errors, again, it will lead to another topic of issue, that is called as how to handle error handling, and how to measure the collapsing quantum states, exactly like what we spoken now. High cost is what a bigger burning problem with quantum. They are trying to leverage that. The Nvidia and other companies are working on high cost, but the problem is, whenever we go for cloud, too costly for us to try out and leverage on it. And lack of industry standardization. We do not know what is the industry standard, because it is a completely a niche skill. Everyone is working on an island. We really do not know what is the standardization that we need to adhere. Basically, in Java, we have something called as sonar cube. We know when a code is written, what is the standardization that we need to follow. And even in automotive world, we have different ASPICE standards and all. Something we have, standards are already there, because it is there for a longer time. Java is there for a longer time. So some standards are already established. So industry lack that universal standardization, because everyone are in the research mode, not on the standardization mode, because we have not reached that stage yet. Now, these are some of the implementation challenges and different levels of implementation. What we have discussed, what are the different types of system? We have seen a foundational model, and a fault tolerant model, and error thing model, and all different types of models implemented. Nvidia is trying to provide chips at with a cooling capacity, with less cooling capacity, with trying to reduce the error, trying to bring to the a general public, to take quantum. Every research is going on very hard, but already there are applications with quantum. We have not, we may not have succeeded that, but we have already started, which is there for a longer time. Because the drug discovery, the personalized medicine. A couple of weeks back, in one of the colleges, I recently attended, Viva sessions, where we have a personalized medicine, exactly the same topic. This is why, see, what is a personalized medicine is, according to your DNA, quantum can make the, chemical composition, simple words. But if you think of a heart surgery, example, if you think of a heart surgery, you are trying to do a different heart surgery, and depending on you, depending on your health condition, depending on the nature, because every human is unique, every human in the world. So for them, how the cells will react when the medicine is given, because for some, for headache, some people will take Saridon, some people will take Dolo 650, some people will take iMode. I don't know. I'm not a we are a different doctor, no, we are not this medicine doctor. But personalized medicine is, it is a very, see, generally we know that drug discovery is already there, but in that, this point number 2 is very peculiar, because recently I've attended some conferences and even in some colleges, people are working on it. According to your nature, what medicine that I can give, or what chemical composition that I can prepare. Medicine preparation itself, it is actually telling like, okay, this medicine has to be, this chemical composition has to be given to this fellow because I have analyzed his DNA and only this medicine will immediately cure. Because the same medicine, whatever we take, apart from general fever medicine, fever tablets, for certain example, like people will tell like, I have a cough. And some people will tell that, hey, drink that X medicine. That is more suitable for him. He told that I drank, it is very powerful. In one night, my cough is gone. But the same thing we will buy, we will drink, we will still cough. That is because according to our DNA, the chemical composture of what the cough medicine has is not suitable. And using quantum now, because you need to analyze DNA, you know we have studied that when you stretch our DNA, you can actually have a very big length of DNA. Normally, a human body's DNA can stretch like anything in real. If you take it really outside and something, so you can imagine how much million parameters the DNA will have. So to analyze the million parameter DNA and to tell you what medicine that for a particular disease that will perfectly suit your body, you need quantum. And this is successful. You can cure cancer and everything in just like that. Again, in some Facebook article or something, we have read someone has discovered something where they have identified a human switch within body. Okay, then when you trigger that switch within the human body, completely the cancer cell is getting disappeared. But they are analyzing whether it is true or not. But he says that I have achieved through quantum principles or quantum mechanics, where with respect to that, if I use some composition, if I touch that, it's like a reset button in your body. Whatever issue you have, everything disappeared. You are as new like anything. He's thrown a bombshell on the medical field. So drug discovery on hearing outside, we know that okay, drug discovery, we are discovering medicines for COVID and everything. But personalized medicine is fascinating. Beautiful research are ongoing. That is the applications on the on that. And one thing on the clean energy, super batteries. You imagine, especially on the simulation world, they are trying to develop the super battery. How it is one small story is, we will try to rush it up. I know it's getting time. One small thing is, you develop a small EV battery for a truck, and you want to test whether my truck will run for how much time. And you'd want to simulate, you wanted to throw down, you wanted to throw down, there is one thing called as here. This I will quickly show this one thing. This is very fascinating one, because we are having eyes and ears for everything. Okay, so here and snap, here maps API tutorial. There are something called as where is that? Yeah, here routing. Yes. So this here routing, this is something, some map. Instead of Google Map, logistics company use this HERE, here map. Okay. So this here map, you can Google it. I will not show, because considering the time, I will not show. You can actually Google it. And if you really look into the here maps, if you really look into the here maps, you can actually see that using here maps, people can actually try to simulate like whenever you are trying to have a EV battery fitted to a truck, when there is a heavy rain, when there is a too sunny and when there is a mountain suddenly coming up, how much effect the battery have, how much life the battery can run before going and advertising like my battery will run for 1,000 miles. We see normally in every advertisement like the battery is everlasting and it will run for 2,000 miles without need for a change in the battery. Yeah, because one of the interesting problem is even there is one electric bus company, a travel company, which is running between Coimbatore and Bangalore, and they are stopping at Salem for recharging the battery for for 2 hours. Now people are got agitated, and very common man has given us some. He is suggesting some solutions, feasible or not, very interesting. Like, why don't you have an additional battery with you so that you can replace the battery and you can run? Why we need to wait for 2 hours at Salem and or otherwise you have a beautiful battery which can run continuously for 7 hours so that it will take you to Bangalore. So simulating things, revolutioning on clean energy, revolutioning on especially on electric vehicles, it is happening. And financial super predictions, very simple. Fraud detections. You know the topic called as underwriter in the banks. Normally, underwriter is a one who normally goes behind you, checks you that do you have a criminal, any case under your name before giving you a loan or something like that. So likewise, the complete underwriter work is being now taken by the machines with intelligence. And for smarter decisions, again, one of our participants have asked, yes, for stock market predictions, why don't we use quantum? Yes, absolutely. When you use quantum, the long wait of 20 years of finding a proper stock exchange algorithm will come to an end. That the system will clearly tell you when you can buy the stock, when you can sell your stock. That is the issue. So smarter decisions everywhere. Fraud detections, yes. So with financial super predictions, quantum applications are coming. Yeah. And AI that thinks like a human. So I've clearly told in an April in an article, they've clearly told if AI can't think, can a quantum AI can think like human? Yes. Because with quantum AI, of course, no system can match humans. Still, quantum powered AI will think faster, can able to relate things, can able to do many things simultaneously, not sequentially. And especially why we are bringing AI that thinks like a human for AI doctors, because they know that the one field which is not conquered properly is health field, healthcare. And whatever you better have solutions you have with healthcare, because healthcare, why people are not accepting AI in healthcare is very simple answer. In any field, if you say that my AI can predict 98% accuracy, 99% accuracy, people will clap and accept your solution with both the hands. Except one field, that is health field, where people will only focus on our solution is not 100% proof, because you are taking risk with a life, human life. So that's why on healthcare, we are AI, quantum AI, quantum computing things with AI powered coming up. Unbreakable security. I don't need explanation for that. I think we have spoken enough in the in the session one, that security will become threat, because using quantum computing, using quantum computers, hackers will break the machine in 3 minutes, 2 minutes. Any banking secure, any banking applications, everything. But as a counter thing, we are using the same, Shor's algorithm, which is actually working on the encryption technique, cryptography. We are trying to secure. So we are trying to provide an unbreakable security. Yeah. And solving traffic and delivery chaos. Yes. The very first thing what we have spoken with quantum is coming in Singapore. That is the only country which has implemented quantum for optimizing traffic. Yes. Quantum can solve traffic. Sorry for the noise. I think if you are hearing some noise, sorry. I'm trying to stop the kids. Yeah. So one thing is I have twin kids, a boy and a girl. So they're very mischievous. Okay. So people always will make a fun of me that I have AI and ML. I have a son and a daughter. It's like AI and ML. Okay. So smart routes and solving traffic and delivery chaos. route optimizations. Yes, I have told, like, if an Amazon guy want to deliver 100 products in a day, which product has to deliver first, which product has to deliver last? Faster delivery, no traffic optimization, everything. In short, if you want to implement a smart city concept, you only solution you have is quantum. That is, of course, it is not debatable. That is the actual solution till now. For now, maybe, I don't know. Tomorrow, apart from quantum, if something comes, okay. But till today, only solution that is visible for us is quantum and space exploration, because you need to travel. Because we have seen plenty of short reels saying that if you are traveling in a light speed, it will take you 100 years to reach the edge of our own galaxy, and it will take 1,000 years to reach Andromeda galaxy, the other one. But likewise, space exploration, we need the fastness. Because one interesting fact is, I don't know whether it will come true or not. People are trying to, invent time machine using quantum. They're trying to invent time machine. They're trying to using time machine. They want to go back and see how the space has been formed 1,000 years back, 2,000 years back, how it is. Interesting one, but we don't know whether it may throw us a surprise. We don't know. But people are trying to do something with respect to the space. Alien hunting is done. And with respect to AIML, absolutely. I mean, cryptography, financial modeling, with respect to the AIML, especially on pattern recognition, on the machine learning models, because normally AIML, slowly people are trying to use a concept called as ensemble learning, trying to combine different model to provide one output model. Example, people are working on a multimodality. Multimodality means we are trying to we are almost done with the solution. We have a solution. Bosch has a solution, and we are actually coming up with that solution. And the interesting, what is the solution is about is, you are driving a car, and you are seeing a restaurant on the road, but you are not able to notice what was the offer that is listed on the restaurant. You are straight away driving on the road, and you ask the intelligence machine, hey, what is the, I couldn't able to see because I was driving on the road. I just had a glimpse, but I couldn't able to read. Did you notice it? Now here is where IoT sensor, again, one of our participant, uh, I just got an information like my internet connection is unstable. Is it fine? I'm there, right?
Yes, sir. You're audible. You're audible. It's clear. Sir, you're audible.
Yeah,
We can able to hear. We can
ma'am,
able to
I'm there,
hear you,
right?
sir. Sir, we can able to hear you.
Ah, okay. Okay, super. Okay, okay. So, so if I ask an AI, one of our participants have also asked the way, Saravanan, where you will use this IoT sensor. Some examples we heard about sensor cameras and all, edge devices, IoT sensors and all. I ask an AI, like, I have seen an offer of a restaurant, but I have not noticed what is that. Did you see it? The AI will be there. It will actually would have noted which eye direction that I am looking into the restaurant, and the IoT sensors actually surround. And now the system will say you, yes, I have noticed that the restaurant has this much offer. That is exactly will match to your food taste. Can I navigate? Can I take you there? This we have already have a solution. We are bringing it to market very soon from Bosch. You will not believe we have exactly to in competition to Alexa. We have solution in competition in competing with Alexa. Bosch has its own solutions in the car. Not only the chip, we produces the airbags, we produces the knowledge, AI knowledge for braking, automatic braking. Now we are producing the personalization effect with AI. So all these things are happening. And drug discovery, I've already told that, this is again not a new, maybe some might be repetition, like we solve optimization problems, that is traffic flow. And drug discovery, we have spoken enough. Material science, we have told that if a battery designer is using a quantum thing in simulating, he or she can learn that this battery life will be there. It can simulate different weather conditions. It can really think the driver pattern. Many drivers will be driving it differently. So based on the driver pattern, based on the weather, based on the battery performance, based on the nature of the terrain, it could be bumpy, or it could be plain, or it could be a mountain region. Everything you can get an answer in very short. So, and it can also, on the material science, we are discovering, like, a new material discovery, where you can trying to map millions and millions of parameters, and you are trying to identify, like, yes, this material could be an alternative for this one. It can withstand the heat or something, so that it can bring some, so that same product with same good quality, but with cost reduced, it can come into the market, so that the company can sustain in the market. So especially automotive worlds are using this material science exploration, because they want, instead of certain parts, they want different material which is very cost effective. And simulations, exactly, I've spoken about the simulation for fleet management, for battery developers. Simulations are done using quantum, they're trying to do. And they're trying to develop artificial intelligence and robotics. You have actually seen how a BMW company is actually trying to produce an omniverse, because where the robotics and everything is there, they're trying to virtually simulate. So artificial intelligence in robotics were enhanced with quantum decision making coming into effect, simulation world, and energy and power grid optimization. Also, we have on the grid management. If at all you wanted to manage the complete energy and power for a whole city, why not? So these are all in focus, which there might be people who are not aware that quantum is coming up. Quantum is not. Research are ongoing to bring solutions at a faster pace in these areas. Normally, people are predicting it in 3.5 to 4 years, but they are trying to bring it fast. But these are some of the areas that is actually in focus. And communication and secure networks. I already told, in cryptography, when you're trying to break any key, trying to prevent it, trying to provide a secure communication. Because quantum has different flavors. Quantum means, quantum computing, quantum communication, quantum sensing. There are different topics people are working on with respect to quantum, apart from quantum computing. But quantum computing will be a horizontal topic across different things. If you take quantum communication, quantum computing plus quantum communication, quantum sensing plus quantum computing. So, and basic thing, faster database search using Grover's. We all seen that using Grover, you can able to do a faster search. I'm not talking about a Google search. Instead, you are trying to do a faster search. One such example is, you have a 20-year-old archived data in your industry or in your institution or whatever it is, and you're trying to say that, you are trying to tell the machine, I need the summary of a data from the last 20 years which is archived, which will exactly match to the HR, which will exactly match to the senior professor, which will exactly match to the assistant professor, associate professor. I will categorize and I'm trying to ask the machine, get me the data of 20-year data, but with for different personas. And it can provide the data in very short time, because quantum can able to do the search simultaneously, not sequentially. Yeah. So, and aerospace and defense, yes, because as I've told, alien hunting and done, it is done. So it is there. And DNA sequencing. I have told you, like, on medical field, personalized medicine. Very interesting topic. Very interesting topic. If it is, it will raise eyebrows for many. If we are succeeding in it. Research is ongoing. And machine vision, with quantum assisted things, how you can do the image recognition, especially for the healthcare. If at all you want to scan an image, if at all you wanted to identify an image, because I was just telling to one of the professors of cornea that, we developed one of the machines with intelligence last year, and we rolled out, and it was with Gen AI concept. We were able to the machine's purpose is, it will identify what was the cancer stage, whether the cancer is in stage 1, 2, 3, 4. When we rolled out as a prototype, it was giving 100% result. We ourselves haven't believed why it was not producing, why it was producing 100% result. We are puzzled, because on the first rollout itself, it is producing 100% result on the prototype model. And we called out every IITs, NITs, because all research fellows, we were using them to develop the product. Everyone was analyzing why. And there is again a group of people. What we done is we have given this problem statement as a hackathon to students, and there was one student community from Bangalore. They were able to provide the solution to the whole management. The solution is the AI is able to take, because normally in Europe, whenever you go to the scanning person, when the cancer affected person patient is going to take a scan, the scan person has a tendency to write on it his own and his or her own analysis whether the cancer is in stage 1 or 2 or 3 or 4 in a Roman number, very minutely, which you can't see it in your naked eye, very minutely at the end of the X-ray. Now, what happened is this AI machine, when you feed something into it, it rejected all the data, whatever you have fed. It is straight away looking into the Roman number. It is immediately saying whether the cancer is in stage 1, 2, 3, 4. That is the reason the AI is a failure. Now, with quantum, this could have been prevented. Yes. And I'm just saying one example of even the latest technology. Still, with the latest one, we are failing. We have error issues and everything. One such example. So with respect to the vision, with respect to the image recognition, we need quantum assist because quantum can handle multi-dimensional parameters. I end with the last slide as we have neared the time. So the key takeaways, I wanted to say is quantum computing offers tremendous potential, tremendous potential, but we still have significant challenges in our hand, and implementations are identified, and industries are in a hurry to bring quantum computing impact at a quicker pace. They wanted to prepone, the quantum impact because the investment has done, and because they want to reap the benefits across different horizontal thing, where when you compare anything with quantum, nothing is comparable with quantum, and because of its huge potential, but again, with respect considering the ethical consideration, we have to be careful. We need to also have a challenges like bringing the error corrections, stabilized quantum, bringing a stabilized quantum machines, bringing error correction mechanisms, trying to reduce the heat, or trying to have the error handling techniques properly. All these challenges are there, but research is ongoing in providing the hardware at an acceptable rate, because today it is costly. You can avail it through service or through customization pattern, but research are ongoing even to eradicate that, so that the quantum potential from quantum computing is observed across different fields. So with this, I end my second session. I thank everyone patiently listening and giving me time. And first of all, thank my Cornea management in inviting me, giving me a chance to share my insights on quantum computing, its implementation challenges, use cases, everything. And thanks for all the participants in patiently listening to me. Of course, you can reach me through LinkedIn. I'm always reachable. We can talk. But if there are any questions, then I can answer.
Uh, Thank you, sir, for sharing your valuable insights and expertise with us today. Thank you for making today's session an engaging and informative session. In spite of your busy schedule, we sincerely appreciate your time and effort in sharing your valuable thoughts and experiences with us. Thank you once again, sir. I hope you have addressed all the questions that is posted in the chat screen. The session two also discovered.
Yes, ma'am. Okay, then I'm happy. I'm happy.
Thank
Also, if
you,
there are
sir.
any questions from the participants later, also I'm reachable through LinkedIn. So no issues.
Thank you, sir. Thank you, sir. You can leave now.
Okay, ma'am.
So instructions for the participants. The feedback form is posted in the chat box. Please fill the feedback form for your attendance.
Okay,
Kindly fill the
I'm
feedback.
leaving now, ma'am. Thank you,
Yes,
everyone.
sir. Thank you
Okay,
so much, sir. Thank you.
okay,
Thanks a lot.
okay.
Okay,
Yeah,
sir. Bye.
bye, all.
Bye, sir. Participants, kindly mark your attendance. After that, you can leave from this link. Thank you. Thank you. Kindly join for tomorrow's session as well. If you have any problems related with your attendance, kindly post your message here. I'm ready to answer. Don't forget to record your attendance. After marking attendance, kindly leave from this link. Yeah, sure. We'll try to share the PPT. You have to check your participant ID from the WhatsApp group or the first mail that you have received from me. Please open the first email communication. In the attachment, the participant ID is there. Please note down your ID for all the sessions while you enter your feedback. Yesterday feedbacks will not be shared now. At the end of every session, you are supposed to record your attendance. So hereafter, yesterday's attendance, only today's attendance only we can able to share with you. You have to mark your attendance in this link. Kindly click on the link and your attendance and the feedback will be taken from this one. It's your responsibility. Kindly go through the email that you have that we have sent. In the email itself, we have given the WhatsApp group ID. So kindly check your mail once again. Kindly copy paste this link in a web browser and then you can able to access the link. Yesterday's link cannot be shared now, ma'am. Sorry. Yes, correct. You have to mark your attendance. Feedback form is counted for your attendance. There is no separate form. So separate attendance sheet. Attendance and feedback form is considered as one. For the entire day, this is the one link that you can use it for record your attendance and feedback. I'm sorry, please refer this link and if you are not able to copy the link, at least you can take a snap of this and you can type it and you can just record your attendance. Open this link, otherwise you just take a screenshot of this link and then put it in the URL and then you can able to fill the form. Those are joining now, kindly be here from the beginning of the session. We can't post uh, because there are many participants are joining late. So please be here from the beginning of the session now. ID, you have to find it from your email. The first communication mail about this meeting link. In the same mail attachment, the participant ID is there. Yes, we'll share it at the end of the session. Not copy. You can click this link and you can able to access it. You just copy paste this in a browser window. It will open, madam. Yesterday attendance will not be shared. Every day the attendance will be closed after an hour. It will be closed. Yes, you can please try. You can open it in your in your mobile or otherwise from your laptop as well. The same procedure only. Yesterday's session attendance will not be given today. I'm sorry. Sorry, we cannot follow. So you are responsible to give your attendance by yesterday itself. End of the session, attendance link will be posted. You have to be here in marking your attendance. Today's attendance already posted. People who joined late, refer this. Kindly record your attendance at the earliest. If you didn't record your attendance in the link, we are not responsible for that. Madam, you have to take care of, and you have to ensure that your attendance is recorded. When you click on the same link, once again, it won't accept your registration, because here there is a limit set it as 1. So one time registration is allowed. So you cannot do multiple registration from the same email ID. So this is how you can ensure your attendance is recorded already or not. I'm sorry, I cannot help you. Daily, you have to record your attendance for all these 6 days. The link is closed, ma'am. Yesterday link is closed. Only today's link alone, it's available. Thank you, participants. After marking your attendance, you may leave from this link. In the WhatsApp group, we are not supposed to post it. Those are attending the session from here itself, they should know the feedback link and they have to mark here itself. We cannot post it for people who didn't attend this meeting in the WhatsApp group. We cannot post the attendance link in the WhatsApp group. We are not supposed to do it. Yeah, you can try, ma'am. Please attend all other sessions as well. You may try. Thank you. Thank you, participants. You may leave. The last minute entry of participants I'm able to see here. So kindly join from tomorrow onwards, from the beginning of the session itself. Thank you. Tina ma'am, you please copy paste this link in your laptop or otherwise in the mobile. The form will open, the Google form will open. It's just a Google form, so it will open. Or just from the screen, you just click on this, you can able to get it. No laptop, at least from your mobile phone, if you click on this, it will open. Or otherwise, you have to copy paste this link in the browser, then the form will open. Or otherwise, you have to take the screenshot of this entire URL of this form. Then you have to manually type one by one characters, then you will get it, ma'am. Thank you all, and you may leave from this link, and we'll meet you tomorrow. Thank you.